Maths 2017 exam on algebra. This is a video for the sine waves question. Okay, let's look at first of all, you've got a table showing the pitch of certain notes and also their frequencies. And the question says, find the equation of a sine wave of a note with pitch D4, which has a maximum loudness of 45 decibels. Well, if you look on the data sheet that we are sent, you'll see that it says Stella finds that the sine wave for a note of maximum loudness 60 decibels and frequency 220 hertz has an equation y equals 60 sine 79,200 t degrees. And also they say you'll notice that 360 times 220 is 79200. So you should find this part here on your data sheet. Okay, so if we now have a look and see what's happening on this equation, and then we'll try to slot into the question that we're actually looking at and see how it changes. So the 60 is the maximum loudness. The number that goes there shows how loud it is, and then this number here is 360 times 220, and then the t at the end, and the 220 was the frequency. So what you've got here is you've got maximum loudness for your first number, sine, then 360 lots of a frequency goes here, then t degrees. So that 220 was coming from there. What we're looking at is for pitch D4. So for pitch D4, we want a frequency of 294 and a maximum loudness of 45 decibels. So it's going to be 45 for your maximum loudness, but this number in here has got to be 360 times the frequency, 360 times 294, 360 times 294 equals 105840. Therefore, you would expect your equation to be y equals 45 sine 105840 t degrees. So there, the maximum loudness, and here 360 times the frequency of a D4 note, and always don't forget to put the T in as well. Okay, question 2. Now this time we're working backwards. It says find the amplitude and pitch which are represented by the equation y equals 72 sine 125640 t degrees. So if we look at this one, okay, first of all it says amplitude. Well, amplitude in this case is the maximum loudness. It's the same thing, okay? So the amplitude is the maximum loudness, which we found was that first number. So that's easy. The amplitude is 72 decibels. Now let's look at finding the pitch. Well, what we did on the previous case, we multiplied the frequency by 360 in order to get the number that comes here. So if we want to work backwards, you've got to do 360 times the frequency is equal to 125640. So we divide 125640 by the 360. So that's 125,640 divided by 360 equals 349. So that's telling us that the frequency should be 349. And so if we want the pitch, we look for 349. I've gone well past it. Its pitch is the note F4. Okay, now the other thing that you might be asked to do is to generalize things. Notice it's saying up here, this again, this has come from the data sheet. An equation can be written to represent this graph. This equation depends on the amplitude A decimals, frequency F hertz of a musical note. So what if we wanted the general equation of a sine wave, a note with maximum loudness A decimals and the frequency of F hertz? Well, as we've said, if you have something that's like this equation here, Then the maximum loudness goes there, so we've got to put the A there, and then this is 360 times the frequency and then t degrees times t. So 360 times frequency times t. Well, this time frequency is f. So all we get is y is A, for the amplitude is the maximum loudness, 360 times the frequency times t. So y is A sine 360 ft degrees. And obviously you could slot numbers in for A, F and T if you knew any of them. Okay, question 4. What transformations map the curve y equals sine t degrees onto y equals 40 sine 79,200 t degrees? And then we've got to follow on by finding the period of the sine wave. So let's do the first bit, the transformation. Okay, well, y equals 40 sine, so we've got a 40 here. Now some people like to bring the 40 onto the left hand side and say y divided by 40 equals sine 79200 t degrees, and then y divided by 40, you do the opposite, a stretch of scale factor 40 in the y direction. Some people just remember, but whatever goes there, that's going to be the stretch in the y direction. So the stretch in the y direction is going to be scale factor 40. Now, the other one is going to be a stretch in the t direction, not the x direction, the t direction, but this one is going to be the opposite of multiplying by 79,200, so it's actually dividing by 79,200, so it's a stretch scale factor 1 over 79,200 in the t direction. So that one in the y direction, scale factor 40, but this one you need to have 1 over it, 1 over 79,200 in the t direction. So that's our stretch. Now we can use that to find the period of the sine wave for this one here, because if we take a normal sine wave, then its period is 360, because the period is the time it's actually taking in order to do one complete cycle, one complete revolution. Okay, so the sine wave, just doing the thing once, like that, is normally 360 degrees. Now, for this one here, which came from the data sheet, you'll notice they haven't actually put any numbers on. And we're trying to find, well, what number would go there on the data sheet for this one. Now, it's easy enough saying, well, how high the thing's going to be. So this one was 1 high, that one's going to be 40 high, the amplitude there will be 40. But that's not what we're being asked. We're being asked what number goes there. Well, we're starting with this graph, and we're doing a stretch scale factor 1 over 79,200 in the t direction. That will give us the period. The other one, the stretch in the y direction, is giving us the new amplitude. So to get the new amplitude, I stretch that way, and that, as I say, would come to 40 here, but to do it this way, I'm going to stretch this amount. So basically what we're going to have to do is we start with 360 and we multiply it by 1 over 79200. Now you can do that on your calculator. You can say 360 multiplied by, and then if I want to, I can do it as a fraction, 1 over 79200 equals, and I get 1 over 220. Alternatively, I could instead have just done, okay, oh, well, I've done it like that, 360 divided by 79200. So if I did instead 360 divided by 79200, and notice it comes to say being 1 over 220. So it's going to be a very small number. This number that goes in there is 1 over 220. But there's an easier way to spot it. This graph here, if we go back a bit earlier, we'll see that that graph there, there's the equation, 79200t there. Notice the frequency for that one was 220. that one there, 360 times 220, that's our frequency. So in actual fact, your period of that is 1 over the frequency, is 1 over the 220. So if you know what the frequency is, you can say that your frequency is going to be 220. Your period is 1 divided by the frequency, 1 over 220. Makes it nice and easy doing it that way. Right, now we've got to solve some equations. If y equals 40 sine 79,200 t degrees, find y after 0.16 seconds to the nearest decibel. Now, you've got two ways of doing this. Okay, the way I prefer is to make sure I'm in mode 1, and I just type this equation in, but I'm going to have to put this expression in, but I'm going to have to put an x instead of a t. So I make sure I'm in degrees as well. And then, if I'm not in degrees, it's shift, set up, 3 to get me in degrees. And then I do 40, sine, and then in the brackets, I'm going to put 79200. I have to put an alpha x, because I can't put t there, close the brackets. And now, all I need to do is calc 0.16, and it will replace the x by 0.16. So I do calc 0.16 equals, there's my answer. To the nearest decibel, it's going to be 38 decibels. So for that first one, I'm expecting to get 38 decibels. Now another way of doing it is to replace the t by the 0.16, do the multiplication there, and then work it out slowly, or you can just work it out. 40 sine, I could do that on my calculator. Instead of having an x there, all I'm doing is I'm going to go times 0.16 equals, and you see you're still coming to 38.04, 38 decimals to the nearest decibel. Now, the next one, however, show that y equals this when t equals 0.003. Now, if it's a show that, it's no good just doing it on the calculator and saying, yes, my calculator showed it. So if I actually am putting this thing in here, okay, if I just say there, well, my calculator says that if I put in 0.003, I get minus 33.8. Okay, that's the three significant figures, because obviously you can't actually do a photo of your calculator and slot it onto your answer page. So we have to do this. If it says show that, we must do it in steps. So let's do it in steps. Firstly, y equals 40 sine, and we replace the t by 0.003. You then work out the bit in the brackets. So the bit I'd be putting down is I'd go 79200 multiplied by 0.003 equals s to d 237.6 degrees. So I work out the bit in the brackets. Okay, then the next thing I need to do is find sine of that. So I do sine answer equals minus 0.844. So notice here I'm putting minus 0.844. And then finally I need to do 40 times that. So I've got that number there. Now I don't do 40 times and type that in again. I've got it here. I just put down it's this multiplied by 40 equals, and it comes to minus 33.77, okay, which then comes to minus 33.8. It may have been better if I'd actually put minus 33.77 first. I think it would be better if I'd put minus 33.77 first and then equals minus 33.8. Then I'm making it really clear to the examiner I know what I'm doing. Right. Next one. Find the first value of t for which y is 30 decibels. Now this is the opposite way round. Instead of being told t, find y, we're told y, find t. So we need to replace the y by 30. So here you've got y equals this. Instead, we're putting 30 equals it. We've got to solve this equation. Okay, now we can use shift solve, but whenever you've got shift solve with a trig graph, you've got to be really, really careful, because you could get all sorts of answers. Okay, and we just want the first value. If you think of what a trig graph looks like, okay, we've looked at some back here. They go on and on and on like that. And so if that was 40 at the top and I wanted 30, I could get that value, that one, all of those that were along at 30. There, it goes on forever. Okay, and I just want this one, so I need to make sure I've got the right one. Right, let's have a look and see what we can do. Okay, what I'm going to do first of all is I'm going to try doing an onion method. So let's have a look. We start with t. You multiply it by 79,200. Then you find sine. Then you multiply it by 40, and we get 30. So that's setting up what we've done. T times 79,200, find sine of it, times by 40 equals 30. Now we come backwards doing the opposite. Okay, I probably don't need that anymore. So start with 30, and the opposite of times 40 is dividing it. 30 divided by 40, 30 divided by 40 equals 3/4 or 0.75. Now the opposite, sorry, we've done that, 30 divided by 40, now we're going back this way, we're going like this. The opposite of sine is sine to the minus 1. So we need to find sine to minus 1, 0.75. Notice I'm going backwards, drawing the opposite. 30 divided by 40, then sine to minus 1 of that. So shift sine to get sine to minus 1, 0.75. I could have done an answer, but 0.75 is quick to type in, equals 48.59 degrees. Okay, so we've got 48.59. And then we're going backwards, so our next one is divide it by 79,200. So we take this number here, divide it by 79,200. Now this time I'm going to divide all of that by it. I'm not just going to type it in again. So I put divide 79,200 equals 6.135-ish times 10 to minus 4. So 6.135 times 10 to minus 4 will do us. Okay, so that means that t, we've got now back to t, because we started with 30 divided by 40, sine to minus 1 divided by that, takes it back to t, is 6.14, that's to three significant figures, times 10 to minus 4. And if you wanted to write that as a normal decimal, 10 to minus 4 means that I need to move everything across. Strictly the numbers go to the right, but most people remember there's a point coming to the left. And basically it was there, 1, 2, 3, 4 point places, or it's still going to have 4 noughts in front. So it's 0.0000614 seconds. So we can do it like that. But you could leave your answer like this. The answer like that is perfectly good. It means exactly the same as that. Okay, let's have a look at some maximum and minimum points. What is the first value? Oh, sorry, I meant to say I said on this one we could go through and do it this way, but you might also want to try shift solve. Let's try shift solve to do this, and there is a way that we can actually do it. Okay, so if we didn't remember the onion method, or you got a bit stuck, or you just want to do a check, I can do this by shift solve. So I make sure I'm in mode 1, and I put 30 alpha equals 40 sine, open the brackets, 79,200. I have to put an x there, and I must remember to close the brackets. Okay, so I've got my equation written down there. 30 equals 40 sine 79,200 x. And I'm trying to solve that to find x. Now, I want to do shift solve on it, but before I do, what I realize is this. I realize I need to be, for the first value, I'm very, very near the start. So I'm very near to x equals 0. So what I'm going to do, to make sure I get this one and not one of these other points that are level with it, because anything level with 30 is going to work, I want the first one. I want the one nearest to 0. So all I do is I type the equation in, then I do shift, solve, but I solve starting at 0. So shift solve, then to 0, then press there, and you notice I again get my 6.135 times 10 to the minus 4, exactly the same answer as I got before, 6.135 times 10 to the minus 4. Okay, which was the same thing as I got down there, or 6.14, I rounded it off. Okay, there it is, 6.135 times 10 to minus 4. So you can use shift solve, but if so, you've got to choose your starting value very carefully. Okay, let's look. What's the first value of t for which the note with this equation here, y equals 40 sine 79,200t, first achieves its maximum loudness? So we're looking at that point there. Well, this one, maximum loudness is 40, so basically it's saying when is y first 40 for this one here. So, replace the y by 40, do the onion method on it. So, start with t, times 79,200, find sine, times it by 40, and it equals 40. Come back doing the opposite. 40 divided by 40, 1. Shift sign of 1, okay. Sine to the minus 1, you probably know this one already. Okay, sine to the minus 1 of 1 equals 90 degrees. So you get your 90. So 40 divided by 40 is 1. Sine to the minus 1 of 1 is 90. Divide it by 79,200. Divide by 79,200 equals 1 over 880. So that value there is 1 over 880. It's a tiny amount of time, okay? About 1 over 880 of a second, okay? So that's the first one there. What if we instead, we've got a different graph now. When does it first reach its minimum, which is down here? Now the minimum for this graph, the maximum would have been 30, the minimum is going to be at minus 30. So we put minus 30 into the equation. There's my equation there, and minus 30. Now let's try shift solve. Start with t, multiply by 118,800, then find sine, then times by 30 equals minus 30. Come back doing the opposite now. This gets a little trickier. Minus 30 divided by 30 is minus 1. But if I do sine to the minus 1 of minus 1, okay, then that comes to minus 90. Now I don't want a negative angle, but with sine, you can always get a second value by doing 180 minus the answer. So I do 180 minus answer. It comes to 270. Because what I did was 180 minus 90. Minus 90 is plus 90. It's 180 plus 90 is 270. So basically, one position, this place here was minus 90. The next one across, that was 90, 180, 270. That's the one I want. And if I've got 270 here, as soon as I've got my 270, I can divide it by the 118,800, and there, 1 over 440. That is going to be the time it takes to get there. Now, this same question, there is another way you could do it, which some people prefer, and also it might depend on how the question's worded, which you want to do. So I'm now going to do question 6 again by an entirely different method. We're looking for when the note first achieves its maximum loudness. Now the first thing we need to do is we need to find what the period is, or the frequency, remember, period for this. So if I take my 79200, divide it by 360 to get my frequency, the period is 1 over 220. We've already done that a bit earlier in the video. So that is one complete cycle going through to there, okay? So that is 1 over 220. That's my period going from here to there, 1 over 220. Now, all I need to do is I need to split it up, and I say, look, I'm actually splitting it into quarters. 1 quarter, 2 quarters, 3 quarters, 4 quarters. So starting at 0 and ending here, I'm going quarter, half, 3 quarters, the full amount. And so the value of t I'm looking at is 1 quarter of that number there. So if that number, for instance, had been 8, my value of t would be 2. It would just be a quarter of 8. But it's 1 quarter of another fraction. So I say the period's 1 over 220. I want a quarter of the period, so that's 1 quarter times 1 over 220. So all I do is 1 over 4 multiplied by 1 over 220. Good, see, I still get 1 over 818, very fast. Now, the next one, I want the minimum point. Now, do you see this time it's 3 quarters of the way across. So, for this graph here, the frequency was 11880. Divided by 360, that gives me the frequency. Frequency is 330. We've again already done it for that graph. Its period is 1 over 330. Okay. And if you know the period is 1 over 330, this time, instead of going a quarter of the way to get the minimum, we go 1 quarter, 2 quarters, 3 quarters of the way. So all I'm having to do is 3 quarters multiplied by 1 over 330. So 3 quarters multiplied by 1 over 330 equals, that's 1 over 440, exactly the same answer as we got last time. So it doesn't matter whether you use this method or whether you use the onion method, you're getting the same answers. Okay, final question. You'll notice that they also, in the data sheet, talked about putting 2 curves together to make another curve. So they took the curve with this equation, added the curve with that equation together, and then they got this one here, and this one, although it isn't a sine wave, is still periodic, because if you look at it, that bit there then gets repeated there, and then it will repeat it again and again. Now, what if we ask for the period of this last one? Well, we already know the period of the first one. It was 1 over 220. We also know the period of the second one. It was 1 over 330. And we're looking at where you get these things coinciding. So we want to get the same numbers. Now, of course, I can do my cycle here. I can keep doing this over and over again. So if that time to there is 1 over 220, to get to there is 2 lots of 2 over 220. And if I wanted to go on to the next one, it would be 3 over 220, and so on. So the period's 1 over 220. To get to the next one is 2 over 220, and so on. But if I cancel it down, if I typed into my calculator 2 over 220, you see it cancels to 1 over 210. So that one is 1 over 220. The next one, 2 over 220, is the same as 1 over 110. And I can keep going if I wanted to. I could do my next one, which would be 3 over 220. That wouldn't cancel. Now let's do it with this one. It goes 1 over 220, then 2 over 220, then 3 over 220, and so on. But let's look at what happens. Sorry, I said over 220. It's over 330. 1 over 330, 2 over 330, 3 over 330. So first one, 1 over 330. The next, 2 over 330. If we type it in there, 2 over, okay, let's do it. It's easier to do it again from the start. 2 over 330, 330, oops, equals 1 over 165, so that cancels to 1 over 165, and then if instead I do 3 over it, 3 over 330 equals, do you see it comes to 1 over 110 again? So basically you can type the things in and cancel them down and see what you get. So this one goes 1 over 220, then 2 over 220, which is that. This one's 1 over 330, 2 over it cancels to that, 3 over comes to that. And what you're looking for is you're looking for the same number. It's happened here, so that means that this one here has a period of 1 over 110. If a period's there, and you can actually see it's lining up nicely. That's 2 over 220, which equals 1 over 110. That's 3 over 330, 1 over 110, and so it's going to be 1 over 110 there. Okay, I hope that helps you with your exam.